Good morning, everyone. Thank you for joining us this morning and accommodating our last-minute venue change. To our friends joining us on the stream, welcome to part two of our apparel and technology kind of deep dives, which is part of our Kite Creates program over at Kite Research Institute at UHN. My name is Garrick Ng. I'm the program lead for Kite Creates. We exist to really create opportunities to bridge the amazing work and knowledge coming out of obviously our kind of research and clinical-based settings and work being done on the innovation side through various creative industries. So we'll spotlight everything from fashion and technology to intersection of gaming and healthcare and tele-rehab, what's happening with immersive media and augmented surgery or training. These are all intersections that over the past few years have really accelerated in terms of potential to unite the amazing creative forces that are happening across different industries. So we have an amazing talk. It's jam-packed with information built on a series that has been designed to cover various aspects of how the worlds of fashion, technology, wearables, healthcare are coming together. If you attended our first event with Haley Stoley-Smith, you would have seen an amazing overview of how, from the perspective of a leading wearables company, sensory capabilities are being integrated into fashion. And today we're going to dig deep into manufacturing considerations. Part three of this, which will be opening shortly, so I encourage you to go to kite-creates.ca to make sure you sign up for updates, not just for events like this, but cohort-based programming and other supports that we have available to support ventures. We'll always be announcing new content as they come. But part three will be looking at digital avatars and how that is helping to kind of change and alter both the design workflow and potentially even engagement in intervention opportunities when it comes to fashion and technology. So I'm gonna leave it there because I wanna make sure that we have lots of time for both an in-depth presentation but Q&As. I will signal from a housekeeping point of view. If you see at the bottom of this screen and others throughout the slide deck, if you go to menti.com and hit that code, we'll be accommodating questions there. So particularly our friends on the stream, please use that actively and we'll be monitoring and trying to kind of guide Ronald as they come in. But it's an intimate group here, so also feel free to raise your hand, old-fashioned, call an audible, and we'll get a good conversation going. So without any further ado, I want to welcome Ronald Tam, lurking behind me, to the podium. Ron comes from an amazing background of serving major brands, sportswear, apparel, fashion, has his own fashion label, so he comes, I think, very credibly from this intersection of fashion design, and he'll be talking in very granular sense about how manufacturing and some of these new, I guess, approaches to integrating technology and wearables into apparel is coming to fore from his very front of the movement or forefront of the movement perspective. So Ron, won't you come join me up here, and the floor is yours.
Thank you. Good morning, everyone. Thanks for being here. Part two of Bridging Apparel and Technology. My name is Ronald Tam, and today we're going to talk about evaluating the feasibility of mass-producing wearable tech. Before I begin, just wanted to apologize in advance. I have a bit of a cough, so if you see me step away from the microphone, it's just I have to get my cough out. It's not contagious. Okay, so without further ado, we have a line of acknowledgement here. Okay, so the purpose of this talk today is to really examine and look at the macro level considerations of mass producing wearable tech and apparel in general. So the good thing about manufacturing or learning about manufacturing is that a lot of the best practices and key principles, which we will look at today, are very universally applicable regardless of what type of product or what kind of technology you produce. It's not strictly for apparel or fashion, nor is it strictly for wearable tech. The key concepts are truly universal in the sense that you can carry the research and the knowledge from one product to the next. So just a table of contents, brief introduction about myself. and then we'll dive right into it. I kind of divided this talk today into 4 key subheadings, if you will. Number 1 is talking about costing and sourcing. It's the lengthier of the bunch because, in my opinion, it's truly one of the most important points to consider and to assess when you're trying to take a product from a concept or a prototype into something that you can mass replicate. And then part 2, which leads into the actual replicating component of it. How do you communicate, integrate, and choose the right manufacturer that can help you produce these type of more novel products that combines textile. Thirdly, we have testing and standardization and quality control, a very key step that I believe every good designer or experienced designer can say, will want to implement quality control. How do you make sure that the product will meet the demands and can sustain its performance over an extended period of time, especially when it's new purchase from the consumer. And lastly, regulatory requirements and general manufacturing standards and principles. Once again, what I described earlier as fine manufacturing, some of the more nitty-gritty stuff such as logistics, importing tariffs, stuff like that, I'll touch on as well. And then lastly, last hour, more questions and answers. I believe the rest of this slide to be available to all of you because I packed all of too much information. And some slides I will talk a little bit more topics that I think are important. Some slides which have a lot of words so that you guys, if I don't touch on everything in depth today, you can download the slide and if you choose, you can do some further research. Because with any type of design, sometimes the products can be so specific to each and every one of you, meaning somebody might be designing an electroluminescence vest, as an example. Someone might be designing a back brace. And because the products in nature can be so varied, some of the regulatory requirements and the quality control aspects can differ quite a bit. But again, on a higher level, it's still generally the same principles. And if you're wondering why there's an octopus there, it's my metaphor for working in manufacturing. So when you mass produce things in textiles and in fashion, and I'm sure in other manufacturing industries as well, you really have to juggle all these topics and more to be effective and successful at it. It's very difficult to isolate or disregard certain components and either try to wing it or tell yourself, I'll deal with it later, because all these components kind of go hand in hand, first and foremost, and they work often in tandem. So you can't, for example, choose a logistics supplier later down the road. You have to consider all these things from the get-go because often it affects things like costing, time to market, how much time it takes for the whole manufacturing cycle, known as lead times, to get the product from concept to finish. So I'll start off with chapter 1, costing your product. Like I said earlier, this is probably the most meaty chapter, and it's the one of the most important ones because anytime you manufacture product or anything for sale, you have what's known as cost of goods. So on a macro level, especially in traditional apparel and fashion, cost of goods is generally calculated with this formula. It includes raw materials plus labor, which is known as CMT, abbreviated for cut, make, and trim, a specific term in the apparel manufacturing sector, any overhead costs, and logistics as well. So with raw materials, on average, for your traditional apparel manufacturing company, raw materials costs typically range anywhere from 30 to 50% of the final cost of goods sold. Examples of raw materials could be things like yarn, finished fabric, if you're buying fabric by the roll, electrical components. So if you have any embedded or integrated technology within your product, this would also factor into your raw materials cost. Trims and notions. In the fashion industry, trims and notions can be things like zippers, buttons, any embellishments that occur on the garment. And finally, packaging. So if you go into any retail environment, you have things like the hang tags, the price tags. We have what's called SKU stickers. So it's the little sticker on the back of the hang tag that has barcodes, a serial number, where an operator can scan and it'll pull up the inventory, the price, and any colors and designations that are assigned to the product. And if you're purchasing items online nowadays, with Amazon, you have a lot of packaging involved in the product getting from the warehouse to you. Things like carton boxes, poly mailers, bubble wrapping, all of that you have to factor in as a business owner or as a designer looking to manufacture. The second highest cost typically is the labor. Again, CMT. The labor cost involves any cutting, prepping, and sewing of the textile component, taking it from, I should say, the initial design all the way to tangible products. Any technological components that you may have, such as assembling the circuitry, any testing of the circuitry boards, or any technology that's embedded within it as well, would be included here. Overhead costs, things like rent, utilities, your typical day-to-day operational costs, subscriptions, because we have so many technological subscriptions, such as cloud storage, things like, if you're familiar with Adobe Creative Suites, which a lot of designers use, Illustrator, all that really should get factored into your cost of goods, because at the end of the day, your profitability is going to be assessed or benchmarked against how much it costs you to make, and you're going to do some quick math to subtract the cost of goods versus your MSRP, which is the manufacturer's suggested retail price, and you have your profit margins. And lastly, very important, quality control and inspection should also be included in your overhead costs. I'll talk more about quality control later, but quality control is typically on a order-by-order basis, meaning per order, you would hire a third-party inspection agency, and they will charge a lump sum to conduct and perform this inspection for you. And at the end of it, you'll have a report from the quality control inspector telling you whether the order was made properly or not. And if it isn't, then it's considered a fail. And finally, logistics. You have shipping and freight and any duties that may be incurred. In Canada, we have different duty rates for different fiber compositions and different product types. I'll get more into that towards the end of the talk, but just to give you a quick heads up, duties are usually divided into two categories, either raw materials, for example, if you're importing rolls of fabric or a box of zippers, that's considered raw materials, and it falls under one category of duties. On the flip side, if you're importing a finished garment, like a fully finished jacket, say from China or India, that would fall under a different category. And depending, again, on what the jacket was made out of, if it's cotton, if it's polyester, nylon, et cetera, there's different percentages in duties and tariffs associated with these products. General rule of thumb, balance is key. So I always encourage when designers are looking to produce their designs on a larger scale to balance your costs. For example, if your raw materials are coming in quite expensive, you may want to consider simplifying the labor and any associated costs further down the road associated with that product, so that you don't over-tip the scale. Because the danger of having every cost coming in too high or too expensive is that when it comes to pricing your product, which retailers or any business owner will typically apply a 2 to 3 times markup at the bare minimum. Wholesale, you're looking at about 1.5 times and up. Once you factor in your profit margins and these scale ups, then your product can become overtly expensive, sometimes pricing yourself out of the consumer's wallets. So this formula, I highly encourage everyone to keep at the back of your heads when you are sourcing your materials, considering what you're making, and even when you're designing, to be realistic with both your resources and ultimately how much that price tag is going to look like, so your consumers don't get sticker shock. Is it called sticker shock? But they get shocked when they look at the price tag. So sourcing. Typically in sourcing, you have your raw materials. If you are incorporating some sort of textile base, you have to consider your yarn selections. And if you're not considering yarn selections, at the bare minimum, your fiber compositions. Like I just mentioned, depending on what type of compositions you're working with, there are tariffs and duties involved. But beyond that, you also want to ask yourself and analyze and probably do some research in terms of what the pros and cons of each fiber or fabrics can yield, how available it is, and any associated dangers or risks involved when using certain fabrics or compositions. For example, in kids wear, there are certain compositions that aren't allowed because it's so flammable, where it becomes a hazard and a danger to the wearer. So it's always a good idea to do some research to, in terms of who your end user is, so that you pick the right fabrics or the right raw materials so that it suits and matches the needs of your consumer. Again, if you have technological components that are going to be embedded, integrated, or somehow synergized with your design, source from reputable vendors. There's a lot of different sourcing avenues in modern day manufacturing. You have your e-com giants such as Alibaba. It's probably one of the bigger ones coming from Asia. You have a lot of trade shows that people can attend and source. And this isn't just specific to hardware. You always want to purchase from certified and reputable vendors. Later in the talk, I'll discuss and examine how do you ask and how do you define certifications when it comes to manufacturing. Region-specific materials. A lot of materials are, or I should say, have competitive advantages in certain regions. And there are disadvantages at times sourcing certain materials from certain regions. A recent example is Xinjiang cotton. Now it's banned in the USA, and Europe is starting to also ban cotton from this region. This is because they have been found to be in violation of human rights. They've been, I don't know if I would use the word hiring, but they've been using a lot of slave labor from the Uyghur region of China. And so the United States was one of the first nations to ban cotton from this region. What that means is any cotton products currently being imported into America, you have to show to the customs certification of where your cotton came from. If you cannot demonstrate where your cotton is sourced from, or if it's just outright sourced from this region, they literally will just turn it around and send it back to the sender. So when you're importing cotton, or if you're looking to sell any cotton-based products in America, always ask your supplier for any certifications and a paper trail of how you can demonstrate that this cotton is not from this region. And beyond that, beyond just the legalities of importing certain raw materials, there are certain advantages in different countries and different nations that exemplify or do a better job at providing these materials. Usually it's due to a number of reasons: geographic advantages, historical advantages, meaning how long they've been manufacturing certain types of products for. And lastly, any currency exchange benefits that may occur. Again, as a general rule of thumb, I highly recommend you to centralize any manufacturing links, if you will, when you are putting together your product. That means, for example, if you're sourcing your raw materials from a certain country or a certain region, your point of manufacture should be fairly close within this region, just because you don't want to be paying such high and increasingly rising logistical costs, because all these things factor into your final cost of goods sold. In addition to that, you have a lot of lag time when it comes to logistics. If you're shipping bulk goods by container load, if you're not renting out or if you're not utilizing what we call a full container load, you do what's called an LCL, a less container load, meaning as the container fills up, then they will ship the entire container to your port of destination. A lot of designers and brands alike, because the quantities that they order aren't massive, they often have to basically wait on a wait list until the container fills up from different buyers. And once the container is filled, then they will ship it out. So products coming in from, say, Asia, for example, can take anywhere from 30 to 45 days landed in Ontario. A little quicker, about 30 days to British Columbia, because the route, if you are sourcing from Asia, India, that part of the world, it goes on a boat if you are what we call boating it. And then it goes to BC, and then it goes on a train, and it comes to CN Rail to Ontario. The alternative is to fly things in, what we call flying things in, meaning it goes on a cargo plane and it arrives in 2 or 3 days, but the price difference is quite drastic. On any given carton or load, you're looking at 3, 4, or even 5 to 6 times, depending on the time of day even. And so as a business owner, you have to be very careful how you move either your raw materials or your finished goods around. And lastly, currency conversion. For most part of the world, everyone uses United States dollars as a common currency. For example, China, in Europe even, if you're trading across the European Union, and I would say most of South America too, they all deal in United States dollars. It's pegged to a lot of different currencies, and in manufacturing, the more simplified it is, the better it is for everyone. So be mindful of when you're buying USD from Canadian dollars. There can be fluctuations in currency, and there could be a lot of savings or the opposite there. My advice when sourcing is to always try from multiple suppliers. You never want to put all your eggs in one basket, because a lot of things can go wrong. A supplier could go out of business the following day. They could face certain regulatory examinations and they fail and they have to shut down for a period of time. Or they might simply run out of a certain raw material that you've ordered. You'll find, for those of you that may have experienced manufacturing or is looking to experience manufacturing, that manufacturers and vendors alike aren't the most trustworthy people. They will often tell lies, quite frankly, just for you to get the order in and for you to leave some sort of monetary investment, usually in the form of deposits. So always take what they say with a grain of salt. I think that's a very safe approach to have. I'm not saying be overtly cynical, but definitely be mindful of how truthful they are when giving you things like timelines, availability. My trick is typically to buy in incremental batches. For example, if I'm trying to buy 500 yards of, say, cotton jersey, I might place a test order of 100 yards. I'll see how long it truly takes them to deliver this order of 100 yards, see if it's reflective of their timelines given. And then if so, I might bump it up to 250, maybe half of my original order size. And again, assess how truthful and how accurate they were in delivering this order, and so on and so forth, until you feel like, yes, over an extended period of time, I've tried and tested this supplier well enough where their quality and their timing is as quoted, and then you have more of a more confidence in buying from the supplier. It's not always good to assume something you order will come on time and as described when it comes to manufacturing, unfortunately. Because truth be told, when you are dealing with overseas manufacturers and even domestic, meaning Canadian or American suppliers, trying to get into the legalities of drawing up purchase order contracts, legal contracts, takes so much time and is not typical, to be honest, in a lot of industries. And so you don't necessarily always have a legal safety net where you can fall back on. And so it's always good to be diligent in advance, proactive, before anything else. And beyond that, you also want to have a point of comparison. What they tell you, as I said, is one thing. What comes back could be something else. If quality is of a concern to you, which in my opinion, should always be, you want to try from at least 2 or 3 different suppliers and see what varieties you can get, whether it be raw materials, trims and notions, electrical components, even things like packaging. There's so much variety in just paper types alone. You want to make sure you're getting the best bang for buck when sourcing. So this page I'm going to not necessarily skip over, but breeze through a little quicker. I've highlighted in bold a couple of very typical manufacturing jargon, if you will. It helps to use your terminologies correctly and name drop them as the situation requires, because a lot of manufacturers you will find are very reluctant to work with quote-unquote newbies to the industry. Why that is because if you are very new to manufacturing, it often takes them a lot of time to hold your hand and guide you through the process. And you will come to realize very soon that manufacturers just don't have that kind of patience to deal with a brand, a designer, or a business owner that is very new to the manufacturing spectrum. And also, you might just get ripped off, quite frankly. So using the right terminologies can definitely go a long way. Some of the more important abbreviations or acronyms, X-Factory and X-Works, that's a key buzzword that everyone in manufacturing uses. What X-Factory or X-Works means is the date mutually agreed upon in which your bulk order exits the factory. It's typically, and I highly recommend it, a pre-agreed date that is both realistic and workable for both you as a designer and as a business owner, and for the factory so that it coincides and works with their production cycle. Generally speaking, for most apparel orders of sizes ranging from, say, hundreds to thousands of units, you will get a quote of roughly, I would say, again, 30 to 60 days of a lead time, meaning when you place the order on day 1, it may take anywhere from 30 to 60 days for the product and order to be completed, which is also known as the X-Factory or X-Works. FOB, free on board, is another term often used in conjunction with X-Factory or X-Works. Free on board means there is a certain price already included in the quotation that helps, or I should say, allows for the manufacturer to deliver your goods to a destination or port of your choice. For example, if you're manufacturing in China, a common port used is either Shanghai or Hong Kong, where it exits on a boat or on a vessel, and then it travels across the oceans to either on the West Coast or the East Coast. And 2 more I want to point out, the piece rate or unit rate. So anything or anytime you order product from any manufacturer, you should be quoted and always ask for the unit price. Never accept a bulk price, meaning just one lump sum for the entirety of your order, because the unit price should indicate very detailedly what per unit that price is, because as your units increase or decrease, that price is very likely to change. So you always want to have as much transparency as possible when it comes to costing your product. And knowing the unit price is a good point of comparison, especially when you compare the pricing between different manufacturers. And lastly, on the top right corner, we have what we call as the plus-minus tolerance, also known as overages and underages. So when you place an order with any factory, and this applies once again to any product, whether it's clothing, shoes, iPhones, watches, et cetera, there's always what's known as a overage or underage tolerance accepted. Again, this is a pre-agreed amount it's an allowance, usually defined in a percentage form of how much the manufacturer can go over or under your order size. For example, I place an order for 100 t-shirts at manufacturer ABC in China. I may agree on a 5% overage or underage, meaning they can produce 5 units over or 5 units under, and I'm still going to accept and I'm still legally bound to purchase and complete this transaction. Why this exists is because sometimes during the manufacturing cycle, products become defective or damaged in the, for example, in the sewing stage, in the cutting stage, or if you have embedded technology, maybe in the integration phase. So say, for example, I have 100 t-shirts that accidentally cut the sleeves off of 2 units. This underage acceptance level will allow them to complete the order and not worry about Ronald canceling the order. Same case goes for any overages. A lot of factories, often as they produce these garments throughout the cutting, the sewing, and the finishing stage, they realize they were more efficient than they originally anticipated. So in instances like this, they might produce more than intended. And so if they produce, say, for example, 3 additional units, the understanding is that the business owner will still take on these additional units. Of course, anything that falls beyond the agreed upon overage or underage, you can technically neglect or forego purchasing or discarding these units. And lastly, once again, US dollars is the global currency in manufacturing. As I mentioned earlier, certain regions have certain competitive advantages, and so it's always beneficial for the designers themselves to take a deeper dive into thinking where you might source your raw materials from. On the right-hand side, I've listed a couple of well-known examples. China is known for producing sportswear, shoes. Nike was one of the first to go into China and manufacture on a large scale their sneakers. India is well known for leathers, cotton-based products. They're on the lower price point spectrum. Turkey and other parts of Europe are well known for their higher end craftsmanship. And so if you're looking for something more high fashion, more high end, with a high level of customization, Europe is a good place to start looking at. On the left-hand side, common examples of why these competitive advantages exist is because of manpower. They may just have an abundance of skilled labor readily available. In a place like Canada, unfortunately, we don't really have a skilled sewing workforce. And so there are limitations when it comes to manufacturing certain types of clothing or wearable tech in a place like Canada. Again, it's because we don't have the skilled sewers because it wasn't a common trade historically. And speaking from experience, no fashion grad wants to become a full-time sewer leaving fashion school. That's just matter of fact. And machinery as well. If you don't have the right sewers, if you don't have the manpower, factories and factory owners aren't willing to invest in the latest machinery to assemble certain products just because they don't have anyone to operate it. So why bother investing in the machinery? And so it becomes very much a vicious cycle of sometimes nothing gets made in certain regions. But on the flip side, you have regions that are heavily invested and heavily training in particular industries, sportswear, yoga wear, athletic wear, even high fashion in a place like Europe. So things can be made. You just have to do your legwork and find out where is it best made in and leverage any resources you have in these regions. One thing I do want to point out is government regulations. In some regions, some countries, Canada is a good example, we have very high levels in terms of how much waste, how much pollutants is allowed when you manufacture. In many parts of Asia, Middle East, India, etc., those regulatory requirements are much lower, for better or for worse. And so manufacturing certain things like dye stuff, when you dye textiles, that's one of the biggest polluting industries ever created and exists. Certain regions have lower regulations. And what that ultimately means is it's easier to have things produced in these regions because the regulations are more lax. The price point will be lower, and you can order in higher quantities. So it's very much a Libra scale, I would describe it as. Where costs are high, it's probably because it's a little more challenging or more difficult, or it's more scarce when you're sourcing these materials. And if it's readily accessible and the price is low, it's probably because they're enjoying certain competitive advantages. And I don't typically get into the moralities of using certain regions that have less regulations. I usually encourage designers and business owners to assess on their own moral scale how that affects their business practices. And finally, supply chains. Learn and understand your flow of materials, meaning really dive deep and understand and grasp the flow of materials that, for example, you buy from, where it needs to go secondary, and where it ultimately needs to arrive at. For example, if you are manufacturing goods in a place like India, and your warehouse is in, say, Texas, but your customer is in Canada here, it may not be smart for your goods to travel all the way to America, pay import duties, tariffs, etc., once it arrives in America, and then bring it once again into Canada, because then you'll be paying double duties and tariffs and HST as well. So it may be more direct to just have India, your point of manufacture, shipped directly to your stockists, your wholesalers in that regard. So always track the flow of your goods, look at the map, assess how that flow or how that journey is most efficient and most economical for you. And I don't say this lightly, there are lots of savings to be had if you plan your route carefully. And on top of just costs, there is what's known as lead time. I mentioned it just moments ago. Lead time is the amount of time it takes to either manufacture a product or simply the shipping time that it takes to get one product from one region to the next. You don't want to bog down that route from having to move materials and goods from one nation to the next, and you might find yourself spending 3-4 months just moving product or raw materials around the world without any getting real results. And so you may have a lot of cash tied down when these situations occur. Second chapter, how do we replicate effectively technology or any textile component associated with it? So if you are designing wearable tech in any capacity, you want to always assess, and probably best assessed at the very beginning, at which part of the manufacturing cycle is the technology integrated into your product. For example, the tech itself can be embedded right at the beginning of the manufacturing cycle, meaning it's most likely integrated somehow into the fabric composition of your end product. There is a lot of companies that will knit or custom weave fabrics based on your yarn selections. And I've worked in companies where they've weaved and knitted conductive yarns made of silver or copper to run circuitry through the the textiles themselves, so that the piece of fabric on its own becomes a circuit board. Alternatively, your technology might be embedded later down the road. For example, a project that I worked on a couple of years ago, it was a electroluminescence safety vest for Canadian Tire. It was a basic construction safety vest with multiple cutout windows that had EL, electroluminescence lamps that flashed at night when there wasn't any headlights or any external light to flash on the reflective elements. And that product required a very simple battery pocket to house the battery pack that came with the vest. And so something like that was integrated in the middle or later down the road in the entire sewing cycle. So always ask yourself and always assess at which stage is your tech integrated, because once again, this will affect what and how you communicate and arrange these, the coordination of integrating or adding your tech into your product. Some mills and some factories are more willing to work with you on more innovative or more novel creations. Some are more traditional and less willing and less flexible to work with designers that have very avant-garde designs. So you want to get this sort of arrangement predetermined and out of the way first, so that as they start production, there's no hiccups or no further questions raised down the road, which might lag or delay your ex-factory date. This is another example of a wearable tech product that I've worked with in the past. It was a biometric monitoring sports bra, and it was fully knitted in Canada, out in Mississauga, and the electrical components came from China, and they were integrated within Canada, all the hardware bits into the knit circuitry, and then sold to consumers in North America. I was in China just last month, doing a lot of factory visits, visiting factories that in my day job we would manufacture with. And I took some behind the scenes videos just because I knew I was going to do this talk, just so you guys can get a sense of, quote unquote, how it's made and in terms of the complexities of adding technology into certain parts of the manufacturing cycle, and at which point do you have to notify your manufacturers. So I'll play the videos. There's no sound because it's a very loud environment and the sound quality is just not great. What this is showing is the spinning of multiple spools of yarn and turning it into a singular elastic type of trim that would get sewn or bound onto a garment. I'll play it once again. So say, for example, if you were trying to incorporate some sort of conductive yarn, you would apply your conductive yarn at this stage where the yarns can be spun together with other yarns such as cottons, nylons, polyester, so that it can be a blend and turn into fabric down the road. Here you have a very traditional circular knitting machine. So this knits a lot of jerseys, interlocks, a lot of even fleece, French terries, a lot of your basic cotton type fabrics are done on these circular knitting machines. And for example, if you are trying to, for example, use silver-infused yarns in your wearable product, which Lululemon does a lot of, they would be incorporating the technology at this stage, meaning the cones of yarns, which you see at the top there, have silver-infused yarns, which the machine will then start knitting, and out comes sheets and sheets of cotton with this composition already included. And finally, this is a sock knitting machine. I've noticed there's a lot of tech often embedded in a lot of sock products for diabetes. It was one of them. I briefly worked on a project that had heating elements for skiers and people that worked in extreme weather conditions, for there to be a heating component in the socks. And so if you are, once again, trying to apply technology, something like sock making goes from yarn to end product very quickly. There's no middle processing, what we call middle processing, meaning it doesn't need to go through a sewing cycle. It just goes from yarn and out comes a finished sock. So if you're working in that sort of industry, you might look at a manufacturer that is willing to apply your tech from the beginning, because there's no middleman to either integrate or embed your technology in between. Next slide. Okay. So here is a very typical example of how a process flow may look like if you're integrating technology into your very traditional sewing line. You'll often have your fabric prepping cutting stage where your patterns for your garments or your product is being cut, bulk cut. Portions of it may be sewn first. In the example I provided earlier, the safety vest, that was first cut, Parts of it was assembled, such as joining the shoulder seams, joining the side seams, and what came out was essentially a shell of the garment. And then we would integrate, highlighted in gray, where engineers and the techs would then build in the circuitry, install the EL lamps onto the vest, and then it gets brought back to the the cut and sew factory for final assembly. And then again, it needs to move back to the engineers so that they can test the final integration of the technology, make sure all the lamps are functional and that it can withstand certain thresholds of pressure, of force. And once all the quality control is passed, then it gets moved once again back to the cut and sew factory for final packaging and shipment. So as you can see, it's a very simple or simply integrated wearable tech product can have multiple flows of back and forth between a very traditional textile garment into a more technologically advanced manufacturer that might handle the circuitry. And you'll find, that, again, depending on how complex or how advanced your tech is within the textile component, this back and forth may exist incrementally or maybe just 1 or 2 times of back and forth. So always try to assess and analyze how this flow may look like, because every time it moves, there's costs and time involved. So when you add all these things together, you may be looking at anywhere from a 6 to 9 month start to finish process. Some additional videos. So this factory was a very large-scale factory just north of the city of Shanghai in China, one of the most impressive ones I've seen personally. It was a 6th-floor factory building, probably the size of like Yorkdale Shopping Mall, not over-exaggerating. And they have conveyor belt systems that move cut panels and partially sewn garments from one floor to the next, because all the movement of these panels were timed, tracked, to ensure that they meet the quota of their manufacturing cycles every day. Why I'm showing you these videos is because you as a designer must take into consideration just how well set up these manufacturers are, because the more established and the more vertically integrated they are, they're often somewhat reluctant, unless your order size is massive, for them to reprogram or remake their manufacturing process. So in a factory setting, you have what's called production managers, and these production managers will design and implement these systems that flow throughout the factory to get the raw materials cut and then sewn and then moved on to shipping. This is one of my favorites. You have a robot programmed to move cones of sewing thread from one area to the next. So this is just how intricate factories are timing and moving their supply chains right now. And so if you are, for example, a designer looking to produce 100 units, and these 100 units require a consistent and frequent movement of raw materials from one place to the next, it would be very difficult for a factory that is as well set up and well designed as examples like these to slot you in, because they would literally have to redesign and reconfigure the entire manufacturing floor, maybe multiple floors, just to finish your product. So you always want to ask and coordinate just how feasible or not feasible your whole cycle can be.
Hey, Ronald, sorry to interrupt, but we're getting our first question in Menti, and I think it might be more related to the last and maybe this slide, so I thought it'd be better to ask it now.
Yeah.
So just to amplify, just show of hands if you have a question. We'll try to squeeze it in. So this question is, understanding there may be overseas production cost manufacturing advantages generally, assume in the fashion industry, do you see opportunities for mid-production of wearable tech to take place in Canada?
Great question. Yes and no. The Canadian landscape has certain pros and cons when it comes to manufacturing. One of the advantages is that the order quantities are usually not expected to be high. Why that is because, as we discussed earlier, the labor workforce, there aren't a lot of skilled laborers. So even if you try to order 10,000, heated socks, you're probably just not going to get that quantity fulfilled regardless who you go to. And so in turn, manufacturers have less expectations of how large these quantities need to be. Is it viable? Again, it's an answer that has multiple levels or multiple levels of consideration. It really boils down to how complex your product is. Something as simple as a t-shirt, I would say, sure, by all means, you can produce a t-shirt equally as well made in Canada compared to any part of the world. But the more specific or the more specialized products you get into, couple of examples for like outerwear in a traditional apparel sense is a lot more complex than a basic hoodie or a t-shirt. So if you're trying to create or manufacture a waterproof, seam-sealed, windproof winter outerwear, it will be a lot more challenging and a lot less feasible to produce locally in a place like Ontario or Canada versus in a country like China, other parts of Asia. Vietnam is very well known for their sportswear and techwear. So in that sense, we won't have the competitive advantage here. Yeah, I would say, yeah, sorry.
Thanks for that, Ron. I'm not sure if this is a follow-up question, so I'll pass the mic on.
Thanks, Ronald. So this is a follow-up question. So I'm basically a textile engineer, worked in overseas. So based on your answer, I have a follow-up question about the manufacturing cost difference. For example, for the knitting cost, in Asia, we produce, for example, per kilogram is like $5 fabric. So what's the costing here? Like if I want to do a fleece fabric, for example.
I would say, I would say when it comes to costing anything, obviously the more information about the variables that you have, the more accurate quotations can be. I have a lot of designers that contact me very often saying like, hey, Ron, here's my design. How much does it cost to make? It's very hard to answer these type of costing questions because variables such as your quantity, how many sizes you have, how many colors you have of a certain product, any additional embellishments, trims, and notions, how the product needs to be packaged, just to name a few examples, all go into the costing exercise and giving you that final cost.
Yeah, if I just go for a gray fabric.
Sorry?
If I just go for a gray fabric, like
gray fabric?
yeah.
I would say, again, if your quantities are within the hundreds of units and you're looking to manufacture in Canada, in Canada, for, say, a 300-unit T-shirt cotton jersey, 200 to 250 GSM, grams per square meter, you're probably looking at anywhere from a good quality one, a $15 to $18 per unit T-shirt. You know, I think there's this myth that T-shirts can be had for $1 or $2. It does not exist. It only exists if you're ordering by the tens of thousands coming from a country like Bangladesh or Sri Lanka, where it's still heavily being developed and that labors and regulations, as we just examined, are on the very low end of the spectrum. Only in those situations can you get these magical $1, $2, $3 price units. But other than that, in Canada, Canada's well known to be expensive in manufacturing. I mean, just look at our minimum wage, right? It's what, 17 something dollars right now, and probably going up in the next few years. And on top of that, you have, you know, employers have to pay taxes, employees have to pay taxes, and the cost of living is just generally much higher in a place like Canada. So unfortunately, it's not often beneficial to compare Canada versus, you know, a developing nation like Bangladesh, because it's not apples to apples, right? You buy groceries in Canada, it's not the same price as buying groceries elsewhere. So it's very hard to compare. I would say to designers that are looking to manufacture in Canada, think of your, you know, the price point that you are looking to sell your product, and work backwards and, you know, truly assess how much finances you have to accomplish this order, and work out a healthy profit margin, and then take it from there.
Great. Thank you so much.
No worries. I realize it's 12:04 already, so I'm just gonna speed through the next few slides. Oh, here are a couple more videos. I will let you watch this if you choose to download it in your own free time. Just a couple of CNC factories that work with metals in China. Once again, when it comes to developing metal components, any metal hardware, such as circuitry boards, et cetera, it becomes a very labor-intensive and systematic cycle that you really have to dive deep in and communicate with to figure out how your products and how your components can be slotted in. This is a plating factory where they dip unfinished metal parts, metal components, into things like zinc, alloy, nickel, copper, et cetera, to give it a certain metallic finish. Another really important slide, so I'll spend a few minutes on this. How do you relay and communicate to your factories to ensure that your manufacturing cycle and that your product gets made accurately and as desired? So if any of you have worked or dabbled in the fashion industry, we have what's known as tech packs, technical packages. In essence, what a tech pack is a instruction manual that instructs and breaks down how your product gets made from start to finish. I have a couple of examples in the following slides of what it looks like. Typically in a tech pack, we have what's called a spec or measurement chart. Spec sheet or measurement chart, the two are the same. And what that is a table of what we call points of measurement, also known as critical measurement points, that define the dimensional values of a certain panel or a certain garment. Why these numerical values exist and why they're important is because these dimensional values ultimately govern how the product fits. For example, if you have an oversized baggy t-shirt, that dimensional value lengthwise and widthwise will be much greater than a slim fitted t-shirt, which those numerical values will be much smaller. And so factories and quality control inspectors alike will match up or measure out these measurements when it comes to inspecting your finished goods to ensure that at least on a dimensional basis, your product conforms as intended and as ordered to your specifications. Because say if you ordered 500 large t-shirts, they should be coming in at 30 inches in length. Everything came out at 35 inches. That's going to be an issue for you and your end user. So spec sheets are a very clear-cut black and white point of comparison where there can be no or very little margins of error. And so that ensures your safety when placing orders for products where fit is a concern and a priority. And on top of that, you can always use mock-ups, prototypes, and any existing samples. Often a good idea to pre-sample, maybe bring your prototypes or have the factory keep copies of your samples so that they have a point of comparison as they manufacture your product from start to finish. And just to add, if your wearable tech product is very technologically intensive, what typically happens is your tech pack just grows in size. Sometimes you might need to bring on engineers who've developed or designed your circuitry boards, the flow of your electrical components. They too would put in their maybe circuitry diagrams into the tech pack so that the whole manual becomes a one-stop shop for your factories and your quality inspectors to refer upon when trying to inspect the product. Just some examples that I've worked on, and the beauty of tech packs is they never generally differ too much from one another. This is obviously a track jacket, kind of like a track jacket design. The pages within it are always fairly standard. Having worked at probably 7 to 8 different apparel companies in the last decade, they all look the same. They just might look differently in terms of layout, but the content is all the same. On the top right-hand side, you have what we call a bill of materials. So as designers, you always want to keep very accurate tabs and tracking of what materials you're using, often known as the bill of materials. You want to define the type of material you're using, any properties such as color, weight, where it's coming from in your bill of materials, so that when a company is trying to replicate your product, what they do is they take this bill of materials, and it's like a shopping list for them. When they go out, not to a grocery store, but to the other suppliers, they'll work through this bill of materials page to ensure that they've purchased sufficient quantities to produce your order. And this is an example of a diagram showing a manufacturer how to measure or what we call spec out your product. Other examples I'll let you browse through on your own time. Here's an example of a spec page from Canada Goose. It was the Chilliwack bomber jacket. So these are all your critical points of measure or measurement points. And it defines, dimensionally what each size needs to be and how to take these measurements. So that ideally, when the parka is completed, all these measurements should match. And if they do match, it's a good, not necessarily a guarantee, but a good read that your garment will fit as intended by the designer. And for something like Canada Goose jackets, we even measured how much down exists in each panel. So we would weigh for example, the sleeve panel, once it's injected with down, we would seal it, put it on a scale, and we would weigh how many grams of down exists in each panel, just to ensure that every Canada Goose jacket was consistently manufactured and that everyone is getting the same amount of down. Because these products aren't cheap by any means, so you don't want to pay $800 just to get half the down of the next person over. This is another quality control component.
Ron, I'm just going to take this opportunity to wedge another audience question in, and it may or may not be directly related to spec packs, but it's adjacent. So this question is, what considerations should be prioritized to ensure the alignment of wearable designs with circular design processes, particularly regarding recyclability and sustainable end-of-life processes? I'm going to ad-lib a bit, again, just reading the room. Right, a lot of the innovation that may be coming from folks in this community might have different stakes when it comes to maintenance of sensors or upgrades as new technologies come along. So I'll wedge that in as well in terms of just future-proofing designs.
Sure.
Have you encountered any novel approaches in your time?
Truthfully speaking, textile recycling and other hardware or components recycling is still, I would say, not at the forefront that it should be when it comes to planning ahead in terms of how to recycle or dispose of these products. For example, Canada still does not have, they've tried, but there's no major organization that will take in worn clothing as an example and recycle it properly. You have initiatives by different retailers, say H&M, there's like a recycling bin that they say, drop your old garments in and we'll give you a discount. There isn't an official body or organization that will handle the recycling or disposal of apparel yet. So with that being said, wearable tech is unlikely to have this sort of organization as of today, as of speaking, where the disposal of it is optimized. I can't speak for the future, but as of right now, there isn't. So to do your due diligence and to be proactive, my recommendation is to be very selective in your yarn choice, in your raw material choice, so that every ingredient that goes into your product is well designed, well selected, and not just willy-nilly and of poor quality, so that you maximize the longevity and the lifespan of your product. And I think that goes a long way to countering things like fast fashion, to counter things like that end up in the landfills very quickly. Yeah, okay. Let me speed through the last little bit. Just some examples. I won't dive too deep into it. This was a technical drawing of the EL vest for Canadian Tire. So something like this, a very simple diagram of how to integrate your tech into your more traditional textile form can go a long way. We designed this as simple and as idiot-proof as much as possible because this vest was being manufactured in China. Canadian Tire did not want to pay Canadian prices, so this was dedicated to an overseas manufacturer. So we had to create all these little instruction manuals for the manufacturer. One thing to keep in mind is a lot of traditional apparel manufacturers and factories aren't very intelligent, to put simply. They aren't going to be engineers. They aren't gonna be like mechanics. So a lot of the times you're really gonna have to hold their hand and like step by step guide them through the entire process. So much so that you may even have to hire certain engineers or certain contractors to be on ground level with them as they finish or as they work through your order. When I did this project for Canadian Tire, they sent myself and 2 electrical engineers to China, and we stayed there for nearly 3 weeks just to ensure that their sampling room and their production cycle understood how to implement these electroluminescent lamps onto a textile base. And we had to translate, do all that good stuff, and again, hold their hand through the whole process. So be prepared and have patience as you work through the integration components, because it's still not mainstream. Truth is, it's just not mainstream. Mainstream is things like H&M, Zara, you know, fast fashion, stuff you see at the retail level, at the malls, that's mainstream. And finally, just some quality control topics I highly recommend you guys to look up, especially the top left corner. These are third-party inspection agencies that you can hire. Anyone can hire these people. SGS, TUV, BV is specifically for European markets. APS Group is for more heavy industries, more engineered industries, so any wearable tech definitely could fall into APS. They have professionals whereby you let them know what you're manufacturing, you supply them your tech pack, your specs, your specifications, and where you're ordering it from, which factory, and they will send someone on ground level to go into the factory and perform a full inspection or partial inspection once all the products are finished and pre-shipping. And I highly recommend this stage. Price-wise, for SGS and TUV for common apparel products, range anywhere from $200 to $400 American dollars per inspection, and you just buffer that back into your final cost of goods sold. Do not cheap out on this step. Highly, highly mandatory, even if it's a factory that you've worked with for decades. We have factories that I've worked with personally over decades, and they still try to, excuse my language, F me over sometimes. So I never skip the step. And also look into this, ASTM standards. So if you're trying to get into like a medical grade product, there are a lot of certifications, and you have to pass through very stringent tests for you to make any medical or factual claims to your product. ASTM is a worldwide acknowledged governing body for all the testing protocols and requirements and the pass-fail standards, if you will. And you can look this up. It's free of charge to look it up. Per test, you can download them. They're like $60 to $80 per test each time every time I looked. It can test for things like, you know, water penetration, how much water can penetrate through a certain fabric, how resistant it is to like flame, to flammability, how much air can pass through certain fibers, so on and so forth. During COVID, I was working for a wearable tech company, and we made face masks. And we did, I think, in total 12 to 13 ASTM standard tests to try to sell face masks to the government of Ontario. We had to test for things like, you know, particle penetration, water penetration, blood penetration, because we were trying to make medical claims on our face masks. And COVID ended before we could even finish all those tests. So, lastly, AQL. The AQL, you'll often hear quality control inspectors, companies like SGS, TUV, talk about AQL. AQL is the acceptance quality limit, which you set as the business owner, as the designer. And what that means is how stringent or how lax are you with that inspection level? It's calculated or defined in numerical values, 1, 1.5, 2, 2.53. What that ultimately means is a percentage allowed of pass-fail. I have examples here. This is a real-life example from a factory that I currently work with. So at the bottom right, you'll see the defect description, and on the right-hand side, you'll see it's listed as critical, major, and minor. So the AQL level for this item, for example, was 2.5, 2.5, meaning I will allow 2.5 times or instances where there is a major issue or major defect within the sampled lot, which I believe the sample size is 125. All these numerical values, how large your sample size is, what your AQL level is. It's all set by you as a designer. You can set it as stringent as you want, or it can be as lax as you want. Obviously, the more tight or the more stringent your quality control is, you'll find that there's often a bit of resistance from the manufacturing side, because no one likes to be, checked up upon. No one likes a super strict, inspector coming in and looking through all their workflows, their processes. So if you feel like the factory is hesitant or reluctant, the moment you let them know your quality levels, standards are fairly high, that could be a red flag waiting for you, meaning maybe they're not too confident in their quality levels and that you might need to maybe look for an alternative or be more realistic in terms of how likely your products are going to be perfect every single time. Obviously, for medical devices and medical garments, that AQL level is the highest it can be, and it needs to be that because to get FDA or FDR approvals in America, it needs to be pretty much perfect. There can be no failures.
Ron, can I slip one more
Yeah.
Menti question?
Yes.
Because I think it may be of common interest, and this is around managing intellectual property. Both existing, right, products like you're showcasing here, and then as we're anticipating products that might involve layers of technology and different IP. Do you have any guidance as to how to approach that topic?
Yeah, definitely. Later in the slides, we have what's called patents and patent filings. You can definitely file for patents, and patents is a great way to, take ownership, take control over your designs. The patent process, as I've listed in the slide, involves 4 different stages. You have to do a search to see if there's existing patents that are similar or close enough to your existing design. If there is, chances are you're going to get declined or rejected right away. If there isn't a similar design within your field or within your industry, then you can apply for it to be reviewed. The application takes anywhere from upwards of a year and upwards. And after it gets submitted, then it gets assigned for an examination where someone knowledgeable, skilled, and employed by the governing body in Canada, it's just Government of Canada, they will have an examiner examine your design, your patent, and then they will follow up with a series of questions to test and analyze just how innovative, how novel, how original, and finally how useful your design is. And if you fail any of those assessments, chances are your patent application will get rejected. But beyond that, in terms of intellectual property, and I'm just gonna be brutally honest, it's very difficult to copyright any technology or any design in the design world, only because oftentimes copycats are halfway around the world, and you're dealing with legalities of cross-national legal battles. Just the time and resources you would spend in trying to hire lawyers, communicate with an overseas, competitor to do all that legal work is often counterproductive to your end goal. Just truthfully speaking, a lot of designers should and will weigh, the pros and cons. How much will it cost for me to patent my design, protect it, and should someone try to copy it, how much is that going to cost, and how much time do I have to invest in figuring out, going through the legwork of suing somebody, for example. And oftentimes, the smarter way to go about it is just to keep innovating. To put simply, I would recommend to, constantly innovate, constantly work through your supply chain, your designs as well, just to ensure that your product stays competitive, stays price competitive as well, and just keep iterating. The more you iterate, the more improvements you will enjoy, and that results often in a better product. And as long as you keep moving your designs forward and bettering your design, then the copycats can't catch up as fast. And I think that's truly the best way and the most economical and efficient way to go about it.
Thanks for that sobering, which turned inspirational. And a personal add on, I just came back from the Consumer Electronics Show, which is the kind of mecca for launching in Vegas last week. And it was that on steroids. Like you could find the next Apple Vision Pro probably for cheaper,
Yeah.
and not just the additional copycat knockoffs, the ones that are even more advanced
Yes.
and impress and not available in our market. So you're seeing this real
Yeah,
time, and that tech cycle is speeding.
Yeah.
So I'm wary of time.
Yeah.
I know you have a lot of content. I just will assure you that if you register for this event, we'll supply these slides to you. Again, I'm not wrapping, but I'm creating space for any final questions. Ronald, amazing journey. Thank you for taking us through such a practitioner-centric, granular view of manufacturing when it comes to textiles, introducing some new considerations when it comes to incorporating technology and wearables. I know some of you may be at this stage, so this is good validation. Others, this may seem far away, but we were very intentional about wedging this level of granularity into our programming to give you something to think about, right? And to really, factor in the resources, whether it's financial or knowledge and capabilities in your team that need to start readying yourself, right? When you pass that prototype or early local batch, when you need to scale, these are just some, we hope, useful, practical considerations for you to build into your planning process. So a pre-thank you, but also an opportunity if there are any questions from the floor you'd like to ask of Ron.
Sure.
Haley, I see a hand up.
Yeah.
Call an audible. I think there are mics here, so just speak up, and our audience online should be able to hear you.
My question is about 3D
Yeah.
and 3D tech packing and 3D
Yeah,
vendors.
sure.
What is your experience so far being with working?
Like clothes, things
Yeah,
like
yeah,
okay,
or
good
broad.
question. So there's a lot of 3D rendering softwares, as Haley mentioned, Clothes 3D being one of the bigger ones. There's pros and cons like everything else. I think from a marketing level, it's very useful for brands to get their concept in front of their audience, and it looks super pretty, very high tech, 3D rotation, great for social media. Is it practical from a manufacturing standpoint? It has yet to get there. I don't want to say it's not going to get there. So Clo, for those of you not familiar with Clo allows a designer, a very traditional apparel designer, to essentially pattern draft patterns in real time on a human form shown as an avatar, I think is what it's called, on the computer, like a 3D live model. And as you draft the patterns, as you input certain parameters of textile, and I'll speak on this too. As you set these parameters, it will sew up on screen what that garment will look like, what it will hang, what it will move like as the avatar moves around on screen for you. So when I was in China, this company that competes with Clo 3D, I forget their name specifically, but they're pretty huge in the Asian manufacturing world. They devised this machine where you can scan a swatch of fabric, you input it lengthwise, widthwise, so cross grain and on bias grain, and the machine will stretch out, pull and tug at this swatch to define what the stretch and elongation, and it tries to define what we call drape in the design world, is of a certain fabric. Because their intention is so that when you input a certain material, say a wool flannel, and I dress this avatar model in wool flannel, that it will hang and behave and look as accurately as it can to real life textiles. Is it accurate? No, it's not accurate. There's a lot of things that it doesn't take into consideration. As well, the patterns that are being produced by these 3D rendering softwares aren't universally readable by other pattern softwares such as Gerber, Pad, Lectra. There is data loss for a lot of the times, and so pattern makers at the factory level have to spend a lot of time breaking down these patterns made with these rendering softwares to double check the work, that it's accurate and that all the dimensional values are the same. So much so that they've told me point blank, hey Ron, if you're gonna use Clo, just give us the measurements, we'll just draft the patterns. So to answer your question, Clo is more so, for speaking from experience, because I've worked with 2 companies now that have Clo, we use it primarily for marketing. When we do sales presentations to our customers, to our buyers, it looks super fancy. You can have your entire line list shown 3D. The colors are rendered, the textures are rendered. Looks great on social media. So if you have an e-com store, before you even have the final sample, you can preview what it looks like, how it's supposed to hang. I say supposed to because there is still some discrepancies between how it looks on the computer and how it comes out in actuality. And finally, probably the most important element that it disregards right now, because right now I work for a development house that we produce a lot of compression type garments. Clo cannot tell the user how comfortable clothing is. And comfort is a huge component when it comes to something consumers wear, especially in the wearable tech world. If you have to wear it, for multiple hours a day because it performs some sort of medical purpose or some sort of biometric tracking, or it performs some sort of heating or cooling activities, just as an example, then there's no way to tell you those type of evaluation points. Yeah.
So I'm going to pass you the mic, sir. Maybe this will be the last official audience question. This is more for folks in the stream, so they can.
What's the current market share for wearable products here in Canada, and what are some of the target areas?
Sorry,
Current market share of wearable products.
like in wearable tech?
Yeah, wearable tech. And
It
what
would-
are some of the target areas?
I unfortunately don't have an answer to that. It would be very difficult to monitor and track, only because wearable tech, the spectrum is very wide. Wearable tech can be, as simple as, antibacterial garments that, a company like Lululemon creates with like silver infused, all these buzzwords, antibacterial, moisture wicking. That could be considered wearable tech. A seam sealed, waterproof, windproof jacket from Arc'teryx is also considered wearable tech. And then you have like super avant-garde companies that produce, biometric sensing, biometric, evaluating products, monitoring heart rates, blood pressure, et cetera, which are also branched into wearable tech. So with such a wide spectrum, it's very difficult to assess and compare like the market share, so to speak. But I think is it Garrick mentioned, at a place like CES, which is a consumer electronics show, if you walk around the show floor, there just aren't many Canadian companies doing wearable tech. Myant, this company I worked at, is probably one of the only few Canadian entities that do engage in wearable tech. Again, because our workforce, our labor resources aren't built for an industry like wearable tech right now. Hopefully things change, but right now, yeah, for like manufacturing, we just don't have that capacity.
Are there any leading target areas that are?
I think the
a little more
states
predominant?
is the state side always has a wide supply of like the engineering fields, the technology fields. Winnipeg, surprisingly, has quite a few factories that can do pretty high-tech cut and sew garments. How I know this is because Canada Goose went and bought out a couple of factories to do their waterproof garments. And BC in British Columbia, where Arc'teryx is housed, they have a couple of factories and contractors, I'm sure, that can produce higher quality, higher end apparel garments. And those type of manufacturers are much more likely and much more susceptible to working with wearable tech designers because they have that sort of flexibility. They have that sort of like, quote unquote, smarts to think outside and work outside the box. If you took your product, like wearable tech product, to like, a mom and pop's contractor in Scarborough, which there are many, they're just not going to entertain those type of orders, unfortunately. And so that market share shrinks in that regards.
So I am going to unfortunately
Yeah.
wrap officially
Yeah.
here, just to respect folks' time. I hope, Ron, you can stick around in case
Yeah.
there are questions that we can kind of huddle and have a brief networking. To add to your last point, though, and I think this is part to this gentleman's question, part of just where we are, state of the nation. A lot of what Ronald has presented us is sort of the trajectory from traditional fashion to then integrating technology versus what I observed last week, which is, through the lens of consumer electronics, there's a whole other push that needs language, that needs definition, that needs boundaries. But you're seeing basically consumer electronic companies venture into wearable spaces because their products are getting smaller, cheaper. I was on a talk with a Canadian lighting company, right, that has product today to serve the gaming community, but they just pre-launched at our talk a mask that may have therapeutic elements, and this is a first for them. They get lighting, but the mask and how to make that comfortable and stylish and all that, that's a fashion question. So I project that there's going to be a lot of that mashing of sectors coming together, where you have innovation coming from traditional fashion, but also innovation coming from hardware companies and gaming companies and VR and AR companies that will require a tactile kind of textile component. So if that's of interest to you, I encourage you. I see Millie Yates in the room. The third of our experimental three-part series on our apparel and technology that I can almost assure you we're going to continue, right? Because the range of topics, we had touched on closed 3D, on avatars, the role of digital design in both design, workflow, marketing. I'll venture to guess those will be topics for our February date, which will be launched soon. Again, we will continue to host not just these deep dives, but general panel talks to kind of expose audiences like this to trends when it comes to the intersection of health, creative tech. I will flag, so to put my friends and colleagues on the spot, that I see Helen and Azadeh in the room. These are kind of the brain children behind our fiber platform, which is informing at a very early clinical, but is also producing some functional prototypes when it comes to helping to shape the direction of Canadian wearable tech and health innovation. So they're present, and I spy, you can't see them, but Anthony Palma, Gita from our team as well, are also ambassadors for Kite. So come, keep coming to these events, come to us. Let's first pause and acknowledge and thank Ronald again for an amazing presentation.
Thank you. Thanks for coming.
Thank you to our friends online and for the tech team that's making all that back end seamless. So I'll officially wrap here, and we may have some drinks and refreshments. If not, all for zero waste. So take some with you on your way out. Enjoy the rest of your day, and hope to see you at our next event. Thank you.